Welcome to another exciting topic on physics with Chris. In today's lesson, we are looking at motion, and under the motion, we are looking at a subtopic we refer to as velocity time graph. Velocity time graph. So, what is velocity time graph? This is a graph of velocity against time. That is, you are plotting a graph of velocity against time. So let's watch this example as I ready to explain velocity time graph. A car starts from rest and accelerates uniformly and reaches a velocity of 40 meters per second after 5 seconds. It then travels with uniform velocity for 10 seconds and it was brought to rest in 7 seconds. Draw the velocity time graph for the motion. Using the graph, calculate the acceleration. Roman figure 2, deceleration, and Roman figure 3, total distance covered. Now, this is how the velocity time graph looks like. You are plotting velocity against time. So this will be your velocity in meter per second. Then against time in seconds. You have velocity meter per second against time in seconds. Now, since the body starts from rest, the body starts from the origin and accelerates. This acceleration until it reaches a velocity of 40 meters per second. That means the body reaches this velocity of 40 meters here. After 5 seconds, then you trace this place to the time. 5 seconds. 5 here. It then travels with uniform velocity for 10 seconds. It travels straight now. Uniform velocity for 10 seconds. So you trace this place to the time again. Now the 10 seconds plus the 5 seconds, the vehicle have traveled 5 seconds before, then traveled another 10 seconds. Then the total time in that case should be the 5 plus the 10, which will give us 15 seconds here. So what will be here will be 15 seconds. That's the 5 seconds from here to here and the 10 seconds from here to here. So the total time from here to here now will be 15 seconds. And it was brought to rest in 7 seconds time. That means the vehicle comes to rest now in 7 seconds. The vehicle had traveled 15 seconds total distance before, then brought to rest in 7 seconds time. So if I add the 7 to this, you have 22 seconds. So the total time spent by the body is 22 seconds. So this is the velocity time graph that you are asked to draw. Draw the velocity time graph, and this is the velocity time graph. Then they say calculate the acceleration. The acceleration is from this place to this place. This is acceleration here. So how do I calculate this acceleration? The body starts from rest. It means that its initial velocity u is 0 meters per second. It reaches this velocity, that's final velocity, is 40 meters per second. Then how long does it take to reach that final velocity? That's 5 seconds. So my time t is 5 seconds. Then using the equation 1 of motion, which is v is equal to u plus 80, I can get my a now. So I will have 40 is equal to 0 plus a times 5. So you have 40 is 0 plus 5a. So in that case, you have 40 is equal to 5a. Divide both sides by 5 now. A is 40 over 5. So a is equal to 40 over 5. That's 8. A is equal to 8 meters per square second. So that's our acceleration. Then to get our deceleration is from here to this place. This is deceleration from here to here. So that's our deceleration. So to get our deceleration from here to this place now, you have, now in this case, since the body is coming to rest from here to here, from this place that the body is coming to rest, its initial velocity is now 40 meters per second, because the body was traveling with a velocity of 40 meters per second before it comes to rest. So in that case, its initial velocity will be 40 meters per second. Since the body comes to rest now, its final velocity will now be 0 meters per second. So for the second one, you have initial velocity u is equal to 40 meters per second. Then you have final velocity is 0 meters per second. The body comes to rest. Then my time in this case will be time from here to here. How long? In 7 seconds. So I'm still looking for A, which is deceleration now in this case. That's what I look for here. Acceleration. The symbol for the two of them is the same. The only difference is that in acceleration it is positive, while deceleration is negative. But the symbol for the both of them are the same. So if I substitute this in my equation 1 also, V is equal to U plus AT. Then I have what's my V now? You have the 0, and this is 40 plus A times 7. So you have the 0 is equal to 40 plus 7A. So in that case, you have the 0 is equal to 40. Collect like times rather. Bring this one to this side now. I will have minus 7A is equal to 40. Then A will be equal to divide both sides by minus 7. 40 over minus 7. So in that case, my A will be equal to 40 divided by, that's minus 5.7 meter per square second. You see that the acceleration is negative here and the acceleration is positive here. So acceleration and deceleration have the same symbol but different sign. So this is about the way you get our acceleration and deceleration. But now they say you find the total distance covered. To find the total distance covered by this car, you need to first find the area of the shapes, then add together. You need to first find the total area of this triangle, or total area of this rectangle, or total area of this triangle, then add together. So let's start now. So I can clean this one. That's the question. If you need the question, you can still go back to it again. So you are looking for total distance covered by the vehicle. So to find the area of A, since A is a triangle which looks like this, A is triangle, then you need to find the area of the triangle. How do you find area of triangle? That's half of the base times height. So the base is from here to here, that's 5, from here to here, and this is the height, which is 40. So if I use half of the base times height, I will have A is equal to half times 5 times 40. That's 5 times 20. This and this can cancel. So you have A equal to 100 meters. Then find the area of the second shape, which is rectangle B, and area of B, rectangle, is length times breadth. So the length is from here to here, which is 10. That will be 10, because that will be 15 minus 5, which is 10. Then the height is from here to here, which is the base, is now equal to 40 meters. So you have 10 times 40. That will give me 400 meters. Then the area of the other shape, which is also triangle. Then area of triangle also now. Area of triangle, in this case, area is still half times base times height. Then the base in this case is this minus this. That's from here to this place. And that is 7. And the height is still 40 from here to here. So if I substitute it, then I have half times 7 times 40. So the area of this one will be half times the area of this place will be 7 now times 20. This and this can cancel out. So in that case, I will have area is equal to 140 meters. So total distance travel now. Total distance should be equal to area of A plus area of B plus area of C. So that will be 100 plus 400 plus 140. So in that case, you have 500, that's 640 meters. So the total distance traveled by the vehicle is 640 meters. So this is example of velocity time graph. Stay tuned to our channel of Physics with Chris and turn the notification button on for more exciting example on velocity time graph.